Here are the solutions to the study guide. We're starting with composing functions. So we're going to add these two functions to make a new one. So order doesn't matter when you add, but it is f and then g. We're going to add, make sure that we can combine like terms. So 4x squared plus 1x squared, negative x plus 2 is positive 1x, negative 1 plus negative 5 is negative 6. Here, order does matter. So when you're subtracting, g is going to come first. And I make sure I use parentheses to make sure I don't make a mistake when I distribute that subtract sign. So g is first, then f. I know my printer is not doing that great a job, but I can still see it. So x squared subtract x squared, they eliminate. 2x subtract 4x is negative 2x. And negative 5. Now be careful, when you subtract a negative, you're really adding it. So it's really negative 5 plus 8. So we have 3 more positives. So it's negative 2x plus 3. Here we're multiplying. This is going to require us to FOIL. I'm going to draw a box. No, it's a binomial times a trinomial. So I'm going to make sure it's more like a rectangle. So I have the binomial on the side and the trinomial here on top. And then I'm going to multiply it. So x times 2x squared, 5x times x. Negative 6 times x. Negative 2 times 2 is negative 4x squared. Negative 2 times 5 is negative 10x. And negative, that's positive 12. So I'm going to combine like terms. So I have 2x cubed. Negative 4 plus 5 is positive 1x squared. Negative 10 and negative 10, that's negative 16x, and then plus 12. Here we're dividing, but we're evaluating at a number. So what I want us to do is to divide, but we're going to evaluate and then divide the answer. So in other words, I'm going to evaluate, and order matters here. F is on top. So plug 9 into the numerator. That's 9 squared, 2 times 9, take away 5. The denominator, 9 squared, take away 8. So 9 squared, that's 81. Here, I'll write it out. 81 plus 18, take away 5. Here, this is 81, take away 8. I can do it. 81 take away 8. Why is my brain just freezing? 73, right? Now, I'm not going to worry about a square root in the denominator. So I'm going to leave this. I'm just going to simplify it. So 81 and 18 is 99. Take away 5 is 94. So this is what we have. I'm going to leave that. Now, if you could square root this, you would. If you could divide this, you would. All right, next one. Next one we're composing. So f composed by g at x. So that means I'm going to do a substitution. So I'm going to write down f, but wherever there's an x, I'm going to put in parentheses, and I'm going to substitute the other equation in for x. So x plus 5 is going to be substituted in, and then I'm going to answer it. So I'm going to FOIL x plus 5, x plus 5. So x times x and 5 times x and 5 times 5. So I have x squared, 5 plus 5 is 10x and 25. I'm going to distribute, so 2 times x and 2 times 5, and then plus 5 at the end. Combine like terms, so we have x squared, 10x and 2x is 12, 25 and 10 and 5 more, that's 40, and you have your answer. Can you compose at a number? So when we compose at a number, it's going to look like this. So in other words, I'm first going to evaluate 2 into g first and get an answer. So I'm going to plug 2 in for x and solve it. This is 2 squared. That's 4 times 5. And 2 times 2. So 20 take away 4 is 16 plus 2 is 18. Then we take that answer and plug it into f. So that's 18 plus 7. That's 25. That's a lot nicer. And the square root of 25, and our answer is 5. Next, this symbol means inverse. So if I want to inverse an equation, we're going to inverse x and y. So we're going to write x equals, and then y minus 5 over 2 minus 4. And then I want to solve for y by doing the inverse of each operation. So the inverse of subtracting 4 is to add 4. The inverse of dividing by 2 is to multiply by 2. I'm going to distribute. That belongs to both the x and the 4. So 2 times x and 2 times 4. And then the 2's divide out. And then y subtract 5. The inverse of subtracting 5 is to add 5. So 8 plus 5. Once y is by itself, you have found the inverse. So I'm going to put the symbol for inverse here. And there's my answer right there. So the inverse of this function is 2x plus 13. All right, let's try again. Can you find the inverse? So we're going to start with x equals 6 times the cube root of y plus 2 plus 5. And then we're going to get y by itself. So to solve for y, the inverse of adding 5, we're going to subtract 5. The inverse of multiplying times 6 is to divide. So I'm going to divide by 6. As soon as I do the inverse, then it goes away. The inverse of a cube root is cube. So I just take x subtract 5 divided and I cube it. And then the last step, and this will give me the inverse, is I'm going to subtract 2. So I have x subtract 5 divided by 6 cubed, and I'm going to subtract 2. And there's my inverse. Not all functions have inverses, only one-to-one. So a one-to-one function is a function that only increases or only decreases. It only rises or only falls, and it has no turning points. This is a quadratic. So if you see the shape of a quadratic, it is not one-to-one. It both falls and rises. It does both. And there's a turning point. So we write down that there's no inverse here. This is a reciprocal. That is one that's monotonic, that only increases or only decreases. So we're going to write down x equals 2, and then that's y plus 3. And then I'm going to solve it. So the inverse of subtracting 5 is to add 5. Now, to get y by itself, I'm going to do the reciprocal to both sides to make it easier to solve for y. So to both sides, I do the reciprocal. And then, instead of dividing by 2, I'm going to multiply. And then, instead of adding 3, I'm going to subtract 3. So if I put this all together, I'm going to write it here underneath this line. The inverse, you have 2 times 1, that's 2 over x plus 5. And then we subtracted 3 after it. And there's the inverse. All right, graphing. When I graph an exponential, I'm looking for 2 points and an asymptote to curve together. So first, identify what the base is. So the base is 2. So I'm just going to write down 2 to the exponent x. That's called the parent. And 2 points that are on this equation. So 1 point on this equation is 0 and 1, and the second point is positive 1 and 2. And the asymptote is at y equals 0. Then I'm going to change these. And so if there is a number in front multiplying, it would change. There isn't. In the exponent, that's the inverse operation. So I'm going to subtract 3 to all the x's. After the exponential, that's k, that tells me to add 1 to all the y's. So I'm going to subtract 3 to the x's. And then I'm going to add 1 to all the y values. So 1 plus 1, 2 plus 1, and 0 plus 1. And then I'm going to graph this. So I'm going to start with the asymptote. You don't have to. Then I'm going to put down the 2 points, and then I'm going to curve it properly. So there it is at y equals 1. We have a point at negative 2 and 3, and negative 3 and 2. You can see these 2 points are rising to the right. And then to the left, it's going to follow the asymptote. It's going to go flat. So an exponential is flat on one side and rises on the other side. If you want to know if this is a growth or decay, is it rising or falling? And you can see it's rising. We call that a growth function. The domain for an exponential is all numbers. There are no restrictions for a exponential. The range has an asymptote. So what's the bottom number to the top? So the bottom number is the asymptote, which is at 1, and it goes to the top, which is infinity. We have a horizontal asymptote at y equals 1, and then the end behavior. So the right end is going to infinity. So right end is as x approaches infinity, the right end goes there. The left end, as x approaches negative infinity, is approaching the asymptote, which is at 1. Here's another graph to try. So I want to graph this one. So again, identify what's the base. So only the base to the exponent x. Then 2 points. So when I plug in 0, any base to the exponent 0 equals 1. And because it's a fraction, I'm going to use negative 1. The base to the exponent negative 1 does the reciprocal. So this becomes positive 2, which is easier to change. And the asymptote is still y equals 0. Then I look for the changes. There's no number in front of the parentheses. That doesn't change anything. There's nothing in the exponent. No adding, subtracting, multiplying, nothing. After the 1, we have minus 2. So the only change is k, which is the y coordinate. We're going to subtract 2. So the x coordinate stays the same, and then I'm going to subtract 2. The x coordinate stays the same. I'm going to subtract 2. And to the asymptote, I'm going to subtract 2. So this is what I'm going to graph. So I'm going to start at negative 2. Draw a horizontal broken line there. And then the 2 points, which are negative 1, 0, and 0, negative 1. Notice these 2 points together are falling to the right. So this is going to rise to the left, and it's going to fall to the right. When it does fall to the right, it flattens out. It follows the asymptote. It's not going to cross over and keep going down. So is this a growth or decay? Notice the graph is decreasing, so it's a decay. The domain, we have no restriction, all numbers. The range, the bottom to the top. So the bottom is the asymptote, negative 2, up to infinity. We have a horizontal asymptote, y equals negative 2, and the end behavior. The right end is approaching the asymptote, which is at negative 2. And the left end is approaching infinity. All right, try the next one. It's always better, you know, to do it first. and then press play and see if you did it correctly. So again, I want to identify what number is the base. The base is always touching the exponent. They're connected. So the base is 4. So I'm just going to write down 4 to the x, and then 2 points there are 0, 1, and 1, and what the base is, which is 4, and the asymptote, which is at y equals 0. So for a parent, only that second point changes. The first point and the asymptote always stay the same. We have an a in front, so I'm going to write it down. A is negative 2. We have an h, the inverse is subtracting 2, and we have k, which is subtracting 1. So a and k affect the y coordinate, and h affects the x coordinate. So I'm going to take the x coordinate and subtract 2. So 0 subtract 2 and 1 subtract 2. I'm going to take the y coordinate. I'm going to multiply and then subtract. So 1 times negative 2 and then subtract 1. I'm going to do it again. 4 times negative 2, that's negative 8. Take away 1. And I'm going to put those 2 points. Oh, and I need to change the asymptote. So if you multiply times 0, it's 0, but subtract 1, and it's at negative 1. So we're going to do the asymptote at negative 1, a broken line that goes over negative 1. Then the points, which are at negative 2, negative 3, and negative 1 and negative 9. And notice, again, going to the right, what direction it's going compared to the left. So for an exponential, one end is going to go to infinity or negative infinity, and the other end is always going to follow the asymptote. So for these 2 points, and where we're going, this is the shape. So if you follow it, it's a decay. It's going down to the right. The domain doesn't change. It's all numbers. The range, the bottom, is negative infinity up to the asymptote, which is at negative 1. The horizontal asymptote is at negative 1. Y equals negative 1. And then the end behavior. So as x approaches infinity, the function approaches negative infinity. That's the right end. As x approaches negative infinity, the function approaches the asymptote, which is at negative 1. So you have the 2 ends. All right, let's keep going. Again, it's good if you try. The base is y equals 1/4 to the exponent x. So the point 0, 1, because the base is a fraction, we're going to use negative 1 and the reciprocal, and y equals 0. What changes these things? So a is negative 1. That changes something. H is adding 1 because it's the inverse. And k is adding 2. That goes with a. So for the x, we're going to add 1. So 0 plus 1 and negative 1 plus 1. To the y coordinates, we're going to multiply by negative 1 and add 2. So 1 times negative 1 and add 2. That's positive 1. 4 times negative 1 plus 2. And then, again, 0 times negative 1 plus 2. That's just 2. The k value will always be where the asymptote is. So I'm going to start there. And then the points, which are at 1, 1, and 0, negative 2. Notice these 2 points going to the right are rising, so it's going to start below and rise and then go flat. This is a rising, it's a growth function. The domain are all numbers. The range, the bottom is negative infinity up to the asymptote, which is 2. There's the asymptote at y equals 2, and the end behavior. So the right end approaches the asymptote, which is 2. The left end approaches negative infinity. All right, some more graphing on this page. So I recognize the base. Instead of e, I'm just going to write 2.7 to the x. That's approximately what e is, so we can graph it. The 2 points are at 0, 1, and 1 and 2.7, and y equals 0. What changes things? So a is negative 3. H, the inverse, we're going to add 1. And then k, we're going to add 1. That changes the y. So to the x, we're going to add 1. To the y, we're going to multiply and then add 1. So we're going to go 1 times negative 3. That's negative 3. Plus 1 is negative 2. It's a decimal. You could use a calculator if you wanted. 2.7 times negative 3. So you are going to use a calculator on this one. So you would go 2.7 times negative 3 and then add 1. Now, I get a fraction. If you have the calculator we have in class, if you want to change that, press mode and go down to the second screen and then change it to a decimal. So press enter. Then the blue button, see where it says quit there in blue and goes back. Highlight over it again, press enter twice, and that's negative 7.1. So pretty well negative 7. And then for the asymptote, 0 times negative 3 is 0, plus 1 is at 1. So remember, the k value is always where the asymptote is. All right, let's graph this. So the horizontal asymptote over positive 1. The 2 points, which are at 1 and negative 2, and 2 and negative 7 approximately. And then draws. Notice the 2 points are going down. So for here, it's going down to the right, and it rises to the left and follows the asymptote. And then can we fill in here? So this is going down to the right. It's decay. The domain hasn't changed. The range, the bottom is negative infinity up to the asymptote, which is 1. The horizontal asymptote is at 1 in the end behavior. So the right end is approaching negative infinity, and the left end approaches 1. All right, the next graph. I know my printer's doing what it's doing. So we're going to start with, so you can see it a little better. I'm just going to move to this piece of paper so it's clearer. Is that all right? So we have this equation. And so that it's just easier to see that because my poor printer's having some issues. So the base is 1/2. So write down 1/2 to just the x. The 2 points are 0, 1, and negative 1 in the reciprocal with the asymptote y equals 0. Here, we can see that our a value, we're multiplying times 2, and our k value, that's at the end, we're subtracting 2. We also have a multiplying. And so instead of multiplying by negative 1, we're going to do the inverse, which is divide by negative 1. To change the x. So whatever I see with x, I do the inverse operation to change it. So if I want to change this, the inverse of negative x is to divide by negative 1. So 0 divided by negative 1 and negative 1 divided by negative 1 is positive 1. That was a little tricky, but this is easier again. So I'm going to take the y coordinate and multiply. So 1 times 2, which is 2, take away 2, that's 0. And again, 2 times 2, which is 4, take away 2. And this is always the k value. And then I'm going to graph it. Again, you do it in your pack. It just makes it easier because my printer was just doing such a bad job. So at negative 2, put a broken line. And then the points are at 0, 0. And 1 and 2, and then this rises to the right, and then you can see it falls to the left. This is growth. because it's rising to the right. Domain are all numbers. The range, the bottom of this is the asymptote to the top. The horizontal asymptote is at y equals -2, and the end behavior. So the right end is rising, and the left end approaches the asymptote, which is at -2. So the growth, domain, range, horizontal asymptote, this is your end behavior. I'm going to go back to the other page. The ones on the left, those printed out better. So again, press pause and do it first. That's the right thing to do, and it will help you because you're doing an exam on this. All right, the base is 3 to the exponent x. So 2 points are 0, 1, and +1 and 3. It's not -1 because we don't have a fraction. We're not doing the reciprocal. And then the asymptote, which is at y equals 0. We're going to change this. So we have a number in front multiplying, that's a. We have a number afterwards, that's k, so it's subtracting 1. And we're going to do the inverse of what I see in the exponent, which means I'm going to subtract 2 to all the x's. So 0 subtract 2, 1 subtract 2. Wait a second, 1 subtract 2, there it is, -1. To the y, we're going to multiply. 1 times 2, take away 1. 3 times 2, this is 6, take away 1. And 0 times 2, take away 1. We know it's just the k value. And then graph it. So that's at -1. And then the points, which are at -2 and 1. And -1 and 5. And then you can see these 2 points are rising. So it's going to rise up to the right, and then to the left, it's going to follow the asymptote. So there's what the graph looks like. This is a growth. It's rising to the right. The domain, all the numbers, the range, the bottom is the asymptote, so -1 to infinity. That's the asymptote, y equals -1, and the end behavior. So the right end is rising. So the right end goes to infinity, and the left end is approaching -1. All right, last one. I'm going to graph it right on it. So, and I'll do the points underneath where it's a little clearer. So the base is 1/3. So I'm going to write y equals 1/3 to the x. So the 2 points are 0, 1, -1, and 3, and y equals 0. We know that's just what the k value is. All right, so then look and go, okay, a is -1. I'll write that down. K is adding 2. There's my asymptote. And then h, we're going to divide by -1. That's the inverse of what I see. So 0 divided by -1 is 0. -1 divided by -1 is +1. We're going to multiply and then add 2. So -1 times 1 and then add 2. That's 1. Again, -1 times 3 plus 2. And then the k value is your asymptote. And then we're going to graph using these. So I'm going to start at y equals 2. I'm going to put the point 0, 1, and 1, -1. So 0, 1, and 1, -1. So you can see these are going down to the right. So it goes down to the right and follows the asymptote to the left. This is a decay equation. The domain is all the numbers. The range goes from the bottom, which is -infinity, up to the asymptote, which is 2. Y equals 2 is the asymptote. The end behavior. So the right end falls. and the left end follows the asymptote, or approaches the asymptote, which is 2. All right, that's a lot of graphing, right? So you should do great on the graphs on the exam. That was 8 of them. Last page. All right, some stories. Some growth and decay stories. Here we go. A 12-foot tree grows at a rate of 3% per year. How tall is the tree after 10 years? So, first, we're going to follow this formula for growth. If it was decay, this would be subtracting. A is the original size or number, original number that we're changing, which is 12. R is the rate as a decimal. So 3% as a decimal is 0.03. And then T is how many years, time, whatever the time is. And then we're going to use a calculator. So if you don't have a calculator, you can follow along. You can go and use your phone. I like Desmos to download. D-E-S-M-O-S, Desmos. It's free. Great calculator. Anyways, here we go. So I'm going to clear this. So 12 parentheses 1 plus 0.03 to the exponent 10. And then I'm going to round. And then I'm going to write a sentence. So I'm going to write down after 10 years, the tree will be 16.127 feet tall. No biggie, right? Just a simple sentence. Did the math, showed me the math. Perfect. In 2021, a $60,000 car depreciates. That means it loses value in price at a rate of 6% per year. How much will the car be worth in 2027? To the nearest dollar. So we're going to use the same formula, but instead of adding, we're going to subtract because we are depreciating. So the original price is $60,000. The rate that it is depreciating at is 6%. So as a decimal, that's 0.06. And then how much time has gone by? So 2021 to 2027, that's 6 years. Subtract, and then use your calculator. So I'm going to go 60,000. 1 subtract 0.06 to the exponent 6. And so to the nearest dollar, it's $41,392. The 1 doesn't make it go up. So then I'm going to write, the car will be worth $41,392 in 2027. All right, let's go. You get a car loan of $40,000 at an interest rate of 6.28% per year. After APR means annual percentage rate, so every year it's being counted. It's not a compound interest question, or it's compounding once a year. After 6 years, how much will that loan be worth? So it's still this equation. So the original amount, which is $40,000 for the loan, we're adding because it's increasing in value. As a decimal, you move the decimal, even though it is a decimal percent. To get rid of the percent sign, we move the decimal 2 to the left. And then 6 years would be that. And then use your calculator. I'll round again to the nearest dollar, so $57,646. And now I'm going to write a simple sentence. In 6 years, the loan will be worth $57,646. So if you ever need to take out a loan to buy your vehicle, the true price of the vehicle is how much your loan is worth, not how much the car is, and so on. It's a good lesson to save first and then buy it, if you can. Here we go. Some more. A 250 gram sample of uranium, radioactive, decays with a half-life of 40 years. How much will be left of the sample after 120 years? Okay. So it's a similar to this decay one, where we're going to write down what we're starting with, which is 250 grams. We're going to go 1 subtract. Now half-life means 50%. So if I think it's depreciating 50%, move the decimal, and it's 0.5. The second part is it's every 40 years, it's that. So every 40 years, like per 40, that creates that ratio per 40, every 40 years. And then the numerator is how many years we're talking about, which is 120. So every 40 years it does that. So the numerator is 120, the denominator is what the half-life is, and then type that in your calculator. You can just type in 120 divided by 40, and you get 31.25. And then simple, in 120 years, is that uranium? Is that uranium, something like that? Will be. And we just said 31.25 grams. All right, we're almost there. You invest $70,000 at this interest rate, compounded weekly. How much will be in your account after 30 years? So when we're compounding, that means that you're calculating interest and adding it back in your account. What does that equation look like? So again, we're going to start with what we're starting with, which is 70,000. Then I'm going to go 1 plus, and the interest rate, which is move the decimal, is 0.0581. I'm going to divide by weekly. How many weeks are there in a year? So how many times will it be compounded and added into your account a year? And we need to know there are 52 weeks in a year. And then we take that 52, so we write it twice, we multiply it by how many years? 30. And that's what we're going to put in our calculator. So we have 70,000, 1 plus 0.0581 divided by 52. And then in the exponent is 52 times 30. Make sure I did that right. Yeah. So that is 399,000. That's nice, right, when it's compounding. So over 30 years it compounded nicely. 399,000. It's almost $400,000. We're going to round to the nearest dollar. Write a nice sentence. In 30 years, how much money will be? $399,623 will be in your account. All right, last one. This goes with the car loan project that you worked on. You get a car loan of $28,000 at an interest rate of 7.25%, compounded monthly for 5 years. What will the loan be worth? So using compound interest, we start with the price, which is $28,000, 1 plus, and then we write down the interest rate, which as a decimal is 0.0725, and divide by monthly. How many months are there in a year? So it's 12 times a year. We're also going to write down 12 times how many years? 50. That tells you how many payments you have, which is 60. So we're first going to see what is the price of your loan. How much really is the cost of that vehicle? So 28,000. 1 plus 0.0725 divided by 12. And then 12 times 5, or 60. And so the true price of that vehicle is actually 40,000, 189. If I round, that would be 190 because of the 0.8. So I'm going to write down after 5 years, the loan will be worth $40,190. All right, so then what will your monthly payments be if you do that? So you have 5 years. So I need to know how many monthly. So monthly in 5 years. So for 5 years, 12 months, how many payments is that, right? So if you're paying every month for 5 years, you're paying how many payments? 60. So then we take the worth of the loan, how much the loan is worth, and divide it by 60. That tells you your monthly payment. So that's 40,190 divided by 60. So your monthly payment for that car loan would be $670 per month. I'm going to let it go and not write a sentence at the end, but you would write a sentence, right? The monthly payment would be, I'll write it. The monthly payment would be $670 per month. You did it. We got to the end. Mr. G Math over and out. I hope you do great on your exam. I'm proud of you for getting to the end of the review packet and doing the best you can. Until next time.